Hello again. We are going to continue our discussion by starting a new chapter on sequences. We are going to talk today about those sequences and how to use proper notation with them. So let's get started. Number sequences basically is just a list of numbers in a sequence. There's a pattern to it, and we need to figure out what that pattern is. So for example, if I have 2, 5, 8, 11, that's a pattern. 4, 8, 16, 32, 64. 1, 4, 9, 16, 25. And so there is a pattern to it, and hopefully I can figure out that pattern so I can figure out any term that comes up later in the sequence. So here's the notation that we use for sequences. I label the first term A1 and the second term A2, A3, A4, and those are the first four terms in that sequence, and those are the variables that I give those first four terms. So in general, AN is going to be the nth term in that sequence. So that's the notation I'm going to use. So if A1, the first term, is 2, and A2, the second term, is 5, and A3, the third term, is 8, what are the next three terms going to be? Well, I notice that the sequence starts at 2 and goes up by 3s. So what that means is if I start at 8 and keep going up by 3s, that means the fourth term is going to be 11. The fifth term, A5, is going to be 14, and the sixth term, A6, is going to be 17. So that's how I use that notation properly. Here's some more examples of finding the next three terms in a sequence. So let's start with the first one. It goes 3, 5, 7. So if I keep that pattern going, it looks like I'm going up by 2s. So the next three terms would be 9, 11, and 13. The next one, 243, 8, 81, and 27. It looks like each term gets divided by 3 as I keep going, so the next three terms would be 9, 3, and 1. Then in the next one, the sequence starts 7, 17, and 27. It looks like I keep going up by 10s, so the next three terms are going to be 37, 47, and 57. In the fourth sequence, it's a little trickier. I'm going 1, 4, and 9. Well, those are perfect squares. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the next three terms are going to be 4 squared, which is 16, 5 squared, which is 25, and 6 squared, which is 36. Then in the last sequence, I've got 5, negative 10, and 20. And it looks like the number part of that gets doubled every time, multiplied by 2. But it also looks like the signs are alternating between positive and negative back to positive again. So I'm multiplying by negative 2 to get from one term to the next. That means the sequence will continue with negative 40, positive 80, and negative 160. All right, so that's how those types of questions work. I may ask you what another term is that is way far down in the sequence, like maybe the 10th term. So let's see how to do that. Let's start with this sequence here. I've got 2, 5, 8, 11, and 14. Well, I'm starting at 2 and I'm going up by 3s. I've ended at 14, which is the fifth term. So that means I've got 5 more terms to go. And so if I keep adding 3, 5 more times to the last number, which is 14, that means I'll add 3 times 5, which is 15, to the last number, which is 14, and I will get 29 as the 10th term. Let's look at a different example where I've got 1, 2, 4, 8, 16, and 32. So in this case, I've ended at the 6th term, and I need to get to the 10th term, which is 4 terms away. And to get from each term to the next term, I keep multiplying by 2. So what I'm going to have to do is I'm going to have to take 32 and multiply it by 2 4 more times to get to the 10th term. So that's going to give me 512. So that's how those questions work. All right, there are two types of formulas that will tell you what any term in a given sequence is. The first one is the easier one. That's explicit formulas. And that means that I'm saying that the nth term is something, it's an expression that's got n in it. So if I want to find the nth term, I just figure out what term I want and replace n with that number, and it will tell me, the formula will tell me what the nth term is. So for example, if I have a sequence and the nth term, an, is equal to n plus 1 squared, what if I want to know the 9th and 11th terms? Well, since I'm given what terms I want, that's the number that's going to replace n in that formula on the right-hand side. So I'm going to replace n with the number 9 to figure out the ninth term, and I'm going to replace n with the number 11 to figure out what the 11th term is. So if I go ahead and replace n with 9, then I get that the ninth term is going to be 9 plus 1 squared, which is 10 squared, and that's 100. The 11th term, A11, is going to be 11 plus 1 squared, which is 12 squared, and that's 144. So that's how you use explicit formulas. Recursive formulas are a little bit trickier because they don't rely on the term number. They rely on the term that came before, or the previous term. So instead of an being an expression that has n in it, an is now an expression that has an minus 1 in it, which is what we call the previous term, the term that came before an. So for example, if I start a sequence and the first term is 3, an equals 4an minus 1 minus 5. What that means is, to figure out any term, I will take 4 times the previous term and subtract 5. So I want to know what the fourth and fifth terms are. Unfortunately, what that means is I have to go through all of the terms to get to the fourth and fifth terms. So the second term is going to be 4 times the first term minus 5. The first term was 3, so I need to figure out what 4 times 3 minus 5 is, and that's 7. The second term is 7. So to figure out the third term, I'm going to take 4 times that second term and subtract 5. So 4 times 7 minus 5 is going to give me 23. That's the third term. So to figure out the fourth term, I take 4 times the third term and subtract 5. 4 times 23 minus 5 will give me 87. And then lastly, the fifth term is going to be 4 times the fourth term minus 5. That's 4 times 87 minus 5, and that is 343. So you see how it's a little trickier when you're using recursive formulas. There is a way to find the formula more explicitly, but that gets into calculus and number theory, and it's more of a senior year type of thing. But you will get there eventually. So if you have any questions for now, please let me know, and I will see you tomorrow.